All right. So what we did over here is we defined our constructor. Again, if I would have chosen that option when I was creating my class, this would have been created for me. But if not, I'm going to do it myself. I'm going to say my constructor. And again, constructor has the same, as always, has the same name as the class. Okay. And if you forget, just look it up. How do you do constructors? Okay. Now, over here, when I say public constructors, I can say, you see this brand name over here? I can call it string, comma, chosen color, and all right. So I defined a constructor. What is a constructor? Constructor is a kind of a method. We also call it a special kind of a method which always has the same name as the class. Okay. If I do not write a constructor, then the Java IDE provides one for me. All right. Inside my constructor, so when I created my constructor, I actually passed 3 arguments within my parameter. Okay, these are all separated by commas, and I passed in 2 string values and 1 integer value. What did I do? The argument that I passed, here, name, this name is basically going to assign the value inside my private instance variable that I defined earlier. All right. My chosen color, actually I said chosen, and chosen color is another string. Whatever I pass as this argument as a string is now going to store the value in color. And of course, an integer argument is going to store the value in my memory. Yes? All right. So now in my computers, I created a constructor like this. All right. Now I'm going to come back to my test object. You see how I have created this object. I'm going to create another object which is going to have the similar signature like the constructor that I defined. So I'm going to say computers maybe I call it different constructor object. Now I'm trying to come up with meaningful names, but the problem with such long names is you're prone to make mistakes, right? So you have to be very, very careful. That's why I always suggest use the assist that you get, okay? Equals, again, new computers. But if you go back and look at the signature, we also call it the signature. The signature of this constructor is that it should take 3 values, 2 string and 1 integer. So I have to be true to that and pass in these values. So I'm going to say Lenovo, comma, silver, comma, 512. Right? Now, with this, I created a new object, right? I can do the same thing that I did over here. So I'm going to go ahead and do this. And basically copy paste it to show you how this is working. So I'm going to change this thing to different constructor object. Right? And I'm going to change, since I'm going to not store this value like this. I'm going to say a underscore different underscore constructor underscore object. And it was the great, what was it? Get brand name, second one. All right. So now let's see what happens. Now I'm going to come in and run. So now errors exist. Okay, let's see what my errors are. So the computers is undefined. Where did I define computers? Oh. PC computer 1. Constructor. Okay. Uh, let's see. Oh, I need to really save this one. Choosing color. File. Maintain the unresolved compilation problems. So there is an error over here. This is giving me that red symbol over here. Okay, line 37. Oh, see, this one little thing is throwing all these errors. I missed a semicolon at the very end. Still did this. I computed his Java line 17. New computers. The constructor. New computers. Oh. All right. So, couple things, and it's good that we got some errors here. The first error was I missed a semicolon over here at the very last line, so it was giving me an error. Although I commented out these things, but it has really nothing to do with it. Because these are my computer 1 and 2, these are my objects that I never used later on. The second thing it complained about is, you see where I am saying computers, PC computer, new computers. So this is my instantiation, right? So this is where I instantiate a new object. Now, what I did initially was in my computers over here, I created a constructor like this. Now look at this signature of this constructor. It said, when I create this constructor, then I have to pass 3 arguments. One is the name, the color, and the value. However, I did not have this one there. And the reason I did not have it was because, remember what I said a little earlier? If you do not write a constructor, Java provides one for you. But as soon as I wrote my own constructor, it overrode on the previous one that it provided for you. However, Java allows you to write multiple constructors. This is another property of object-oriented language. It lets you override, which means you can write multiple constructors given that you have different signatures, which means this one is a constructor with a signature which takes in 3 arguments. This one is another constructor constructor with a different signature, no arguments or parameters. However, in this one has a specific signature and 3 arguments. All right. So what happened here was when I created my computer test object, I created this one, which is actually the second default constructor that I use, which no arguments, right? But then to put in value in these objects, I use a set brand name, set color, and set memory. However, when I created this new object called a different constructor object, I followed the other signature of a constructor where it actually took in the 3 argument, right? So that's why when I called those values by using the get color, get memory, and get this, associate that with the new object that I created, it returned me the values that I passed in my Lenovo Silver and 512. You guys with me? So here is the use of a constructor. In Java, you can write as many constructors as you want, but again, it has to be a different signature. So given this, I passed in a constructor with 3 arguments. Can you write a constructor with 2 arguments? Absolutely. If you say I want to pass in only the color and the memory, I can do that. When you create that object, you have to use the same signature and pass those 2 arguments. All right. Now another thing, when you write the constructor, then when you create the signature over here, you see how the first one is a string, the second one is a string, the third one is an integer. You have to follow the same order. When you create and pass those values, you have to pass in 2 strings and 1 integer. You cannot mix match. Remember what I said earlier? Computers are dumb. So if you say, this is my signature, I'm going to take 2 strings and 1 integer, that's fine. That's exactly what it is. Now, you can always say, I passed in string and a color, but when I'm inputting the value, I'm going to flip it and actually put in color here and name here. Is the computer going to recognize that? No. Why? Because the computer only checks to see if the value that you're inputting is a string or not. You can still trick it. You can, instead of a name, you pass in a color. Computer would have no clue. Okay. Now you can write your program where you can check, right? If you say, okay, my allowable colors are black, silver, and red. You can write, and we'll talk about that later on. I can write a try and catch statement where it says, check to see if the values are either black, red, or this. If not, that's a wrong input. I can make the computer smart, but that's all depends upon the programmer, right? So the important thing to remember here is when I create the signature, I have to follow the same order. So if I create 2 signatures, one with name, one with memory, when I create another object out of this, I have to pass in a name and a memory or an integer. And then I can use, see the versatility over here. I have these set methods and get methods. I also have a way of passing everything in one shot. Okay, so when I created my object, I can have it all in one shot, or I can come in and use my set methods and then use my get methods to get these values. We're good? Clear on how we use constructors. Okay. Now, again, one thing to remember is as soon as I wrote that constructor with a signature, it actually overrode the default that was provided, and that is why it was giving me an error. It said, I don't see this signature where you are creating this, line number 18, because it says new computers with nothing. So I had to come back and redefine this one like this. It was an empty block, but I still had to do it, otherwise it would not recognize. With me? So if I would have taken this one out, line 26 to 29, if I comment this thing out, it's going to again give me an error saying, hey, you are creating an object in line number 18, which says PC computer 1. It is going to be looking at a constructor computer with no argument list, but you have not defined it in your class. So I don't understand what you're saying. So that's why I had to go and create that. I can, as I said, write multiple constructors, and with one argument, with two argument, with three argument, with no argument. This way it creates versatility and it lets you do it again in one shot, like this object over here, or in two shots where you create an object and then you use your set methods, and then your get methods and get methods. And over here, I just completely took it out by calling in again, associate my object with my get method, and get method. And remember, use that assist, because that name that you're coming up with, it's again, you're free to come up with your own name, but that name that you assign, you have to refer that object with that same name, otherwise it's not going to recognize. All right. Question? Done? Okay. For your class assignment, I want you to do these things. Number one, I want you to create another constructor, but this time with two argument lists. All right? Make the program interactive, where you are not putting in these values hard-coded. You're bringing in a scanner. You're asking the user, input the name of the computer, input the name, input the color, input the memory, and then associate them with the correct object, and then display them. You're good? Okay. So let me finish out by going over what we were talking about here. This is still, no, it's not the right one. Figure 3.5, okay. So this is our, this is where we stopped initially. So we were talking about how I can make the program interactive by adding the scanner object, which you have already used in the prior chapter where you define some variables and you took those values in. So same thing over here. So once the way I instantiate an object, already talked about that. Talked about the constructor. It is similar to a method, but it is called implicitly by the new operator to initialize an object's instance variables. Okay, and again you can override. So once you create that object, you can call those methods that you have defined in those classes associated with that object. Remember, it also keeps its own copy. Okay. And then it says, you know, you can use the print F or you can use the print line, but with an F you can, you know, do the control the formatting of the print. Splitting the statement in the middle of the identifier, that's okay. Okay, we already talked about if you do not assign a value, by default it is assigned a null value. Local variables are not automatically initialized, and you have to have a default value there. Set name method, again, we already used that. Once you create that method, You have to look at the signature and you have to pass in the right argument. Otherwise, it's going to give you an error. This one shows about how to, do the compilation. And again, we use the run command or the icon that we have, so we don't have to do this. Now, this is important. This is the UML diagram. So what it's telling you is, in programming teams, all these things that we talked about as our objects and class, this is kind of represented by this, okay? So I'm going to minimize this. I'm going to open this thing back up. This is the active inspire, which is, here we go. So in one of your assignments, I'm going to ask you to write an UML diagram. And generally people make a big thing out of it. It's really very, very simple. You can handwrite it. There are some tools, like there's an UML modeling tool that you can use, but you don't have access to it probably. Or you can use Word document. You can even use Visio. Okay, and this is what I mean. Flip chart. So when I remember the example that we created, we called it computers. So I would define So I would define I had name, string, color, string. Actually, it's actually 3 of this thing. This is the name of the class. And then you had memory, right? Int, right? And then you had set underscore name. So what it's telling you is basically, if you guys are working in a team and I need to pass some information to Caroline. I said, okay, I have created an object and I'll draw something like this. So she'll immediately know that there is a class called computers, which has 3 instance variables, and there are some methods. Okay. I create another one and I call it students. And again, this is where I would define my variables. This is where I would define my methods. So variables, methods, and name of the class, right? So that's basically what an UML diagram is. And in your program, as I said, I would ask you to write or draw a UML diagram. So anything that you just did, just take it and create something like this. It's really, really simple. If you look at the So here is the name. So there are 3 compartments: account, name. Oh, we also do a plus sign. Okay. Name, string. So again, I actually drew that UML a little differently, or not quite correct, because you have to say it's a name, set name, and get name. And so this one basically says the middle compartment contains the class attributes which correspond to the instance variable of the Java. That's the middle compartment. The bottom compartment considers the classes operation which correspond to the methods and constructors in Java. I only showed you the methods. And also, private attributes are preceded by a minus sign. The plus sign tells you it's public. So these are the way you communicate. So when you are working with UML diagrams, so somebody's going to give me a UML diagram and I would know exactly when I see a negative, I know it's a private variable. When I see a positive, I would know it's a public variable. And then it listed by the operation name followed by a set of parentheses and then, public method. So basically these are some of the rules. It also tells you the return types. The UML indicates an operation's return type by placing a colon and the return type after the parenthesis. So now if I go back to this, so name is a private method, a colon, what does it return? String. A public method, name of the method, it returns name, which is a string. Get name, right? No argument, but it does return a string. So this is a set name method. It sets a string, it accepts a string value and sets it in the name. All right? Plus tells you it's a public method. Negative tells you it's a private method. Name of the account. So this is my UML diagram. So by looking at the rules, this one and this one, you should be able to create a UML diagram of the class that you just did. All right. This part gets into a little bit of the static versus non-static. Now this is something that I said we will talk more about it later on. So when we say we have a static method, what it's really telling you is you must call most methods other than the main explicitly to tell them to perform their task. A key part of the JVM Java virtual machine is to locate and call the method main to begin the app's execution is the static keyword. So by saying the word static and also by having a main method, the IDE knows that I'm going to call in the main method so that I can start compiling. Okay. Also, it tells you is which indicates that main is a static method that can be called without first creating an object of the class in which the method is declared. So with a static, I do not need to create an object to call that method. Whereas a non-static method sometimes is going to be the one where you have to create an object and then call that method associated with that object. Okay, so that's why in the very beginning I did not want to confuse people, because static is in the way, the simplest way to remember is, remember your main is always static and you never have to call anything. You just say system public static void main system out and you start writing your program. You don't need to create any object for that. However, some of the other ones are non-static. So the methods that are non-static, you don't need to really write it. So you never say public non-static set name. Okay, you only write it when it's static method. All right, so by default, most of the time, these are non-static methods. You do not see the word non-static in front. However, if you but you will see there are going to be methods that we're going to define as public static. All right. All right. The library of Java is actually brought in with an import statement. So far, you have only seen one import, that was the scanner. As soon as you type in scanner, it tells you, okay, I need to import some library, and I just bring in the util library, and it brings the whole thing with us. So basically, it's telling you that in Java programs must be imported explicitly. There is a special relationship between the class that are compiled in the same directory. By default, such classes are considered to be in the same package. All right. So remember in the very beginning, it talked about the package. I said just leave it for right now, but I wanted to kind of explain where that package comes in. So basically, everything within that project folder is now considered one package. So by default, such classes are considered to be in the same package, okay? Known as the default package. Classes in the same package are implicitly imported into the source code files of other classes in that package. So if you now create this package and put it as an import statement at the top of the another program, everything that you wrote over here is now going to be imported in that one, right? So this is an import statement. This is, again, sometimes they're not required because by default it has some of those things like system out. You don't have to write anything. That comes from the default package. However, if it is a map, a special kind of map, if it's a special kind of a scanner object, you have to write that import statement. So an import statement declaration is not required if you always refer to a class with this fully qualified class name, which includes the package name. Okay. However, we do. It does not require the import declaration of the Java source code, but there are some that I'll point out to you that will need the import statement. Okay. All right, this is something that we already talked about, information hiding. So declaring instance variables private is known as data hiding or information hiding. So basically the concept is when you define a class, you define all those variables as private, because you do not want people to come in and change those things. If you want to change something, you always have to go through the public methods. Remember that analogy that I gave? So when you go to the faculty suite, individual offices may be private, but you have to get access to it through the public method. So unless you go through the public place, those are all private. Okay. And this is also called information hiding in programming languages. All right. We talked about the access modifiers. Now remember, access modifiers are public, private, protected. Okay. So those are called the access modifiers. Okay, this is how sometimes it's defined. So software engineering with private instance variables on public set and get methods. So if you have your name method, that is kind of private, but you have your public get name and set name method that would let you put in values in name and extract the values out of name, your private variables. Okay, so again, just like your UML diagram, this is how sometimes they designate the private instance variables like this. Okay. We already talked about this. Each class you declare can optionally provide a constructor with parameters that can be used to initialize an object's class when the object is created. Java requires a constructor for every object that's created. Right? If you do not provide one, by default you are provided one, and that's the one with no arguments. But as soon as you write your own, it overrides the one that you created. However, you can always override and have multiple constructors. Okay. Here's an example. Public account. This is a constructor, right? How do we know? Because it has the same name, and always, anytime you see a constructor, you should be able to identify because that would have the same exact name as your class. Okay, so this is a constructor, and constructors are nothing but special kind of method. As you can see, it would have an argument. In this case, they defined their own. They passed only one argument, which is of the type string. And what they did was, again, your question, Carolina, why is it that I'm using this? Because I named it differently. Remember when I defined my constructor with 3 arguments, I could have used the same exact name as my private variables. I could have named name, memory, and this. In that case, I would take that name and say this name. All right. I just did it because I know a lot of times people get confused. Is this the same variable as this? But remember, these are all local. Okay. So as soon as it assigns the value, it's done. Okay. So that's why, since I have the same variable name that I defined, that's why I am utilizing or specifying that this name, which means the name that I take through here is now assigned to this name. With me? All right. Set name, get name, again, since the same thing, that's why I'm saying this. And of course, get is going to return my name. Okay. Even though it's possible to do so, do not call methods from constructor. So within constructor, you can write methods, but this is not the good thing. And we'll talk about it later on when we talk about polymorphism in interfaces. So we'll talk more about these. Are again concepts that we'll talk about later on. All right, this is the part that I already mentioned. Default constructor. If a class does not define a constructor, the compiler provides a default constructors with no parameters, and the class's instance variables are initialized to their default values. Does it make sense now? So when I did not define the constructor, it created its own and it gave the default value. So if it was a string, my default value is a null. If it's an integer, my default value is a 0. And there's a little section in the book, it tells you if you do not define, what are some of the default values. Okay. Now, if you declare a constructor for a class, the compiler will not create a default constructor for that class. And that is exactly what had happened. It overrode and I had to come back and write it. Otherwise, it would not recognize that. All right. So here we go. Account 1, James Green. Why did it do it like this? Because if you remember, the signature was constructor, 1 argument. Okay. That's why if I want to create an object called account 1, I place this. Now you can always come back and say, I don't like doing it. I want to do it as default. You can always go back, create another constructor, default value, and then use set and get to assign those values. All right. So here is again the UML of that account. So it's private, string. It tells you this is how you denote that we actually have a constructor called account, and it will take in a string value. Public method called set name will take in a string value. Get name, it will return a string value. You with me? All right. These are my float and double. We always dealt with string and integer, but this is my float and double. So it does provide 2 primitive types, float and double. We, for our programming purposes, use it interchangeably. However, if you want to be very specific, then you can identify your float and double. The difference is the kind of value it can store. So I think if you look at this, I think variables of double float represent double precision floating point numbers. This requires twice as much memory as float variables and provide 15 significant digits. All right. So remember, I think I made a statement here earlier, or maybe I made a separate one. If you are talking about an interest rate on $100, 0.2%, if you use a double or a float, not a big deal. But if you're trying to write a program for NASA where your rocket is going to go hit something, that precision is required and you have to choose the right kind of variable. Otherwise, you're going to lose out. So if you say 2.02, In double, in variable, it could be 2.021346. It can go all the way up to 15 digits to be that specific. Okay. So again, depending upon what you're doing, that precision matters. For most of the programs that we write, we are okay. But you need to know that there's a difference between why you would choose one over the other. And of course, as you see, these require twice as much memory as float. So the difference between float and double is going to do a lot more, 15, but takes a lot more space. Okay, so now I create, what kind of method is this? Constructor. How many arguments? 2. Name and balance. This dot name, so the name that you put in, stored in name. And look at what we have over here. So inside, I have this balance gets stored over here, but I wrote a little if statement here. If the balance is a positive, 0 or positive, then I'm going to store that in. If it's a negative balance, I'm not going to store it in. Okay. Remember, initially I was asking, I was saying, what if you flip the name with a color? Can you do that? Yes. In this case, you make the program a little smarter. What if you try to put in an account a negative balance? It's going to tell you, I'm not going to store this because I put a little if condition here. Only if you have 0 balance or a 1 cent, I'm going to store that balance here. If it is a negative balance, I'm not storing anything. All right? Get name, okay. So here we go. Jane Green, $50. John Blue, negative. Now with this one, it's not going to store that value, right? Okay, so I did this. Again, this should be pretty simple. I have a scanner input. So let's go to the program. Scanner, no question here. Public class account test. Public static void main string. Remember, this is my account test, so I have created another class called account previously. In that one, I defined some constructors and I'm following the same signature, which is providing 2 arguments. Now, I provided the 2 arguments, but in my check, I also made sure I made it a little smart. The 7.53 is not going to be stored because it's less than 0. Then I system out print line. I say %s, that's a string placeholder. I say balance equals %.2f, 2 float decimals, % in new line, right? And then comma, parameter list, my object name dot the method that I'm calling. Again, comma, account1 dot get balance. So look at what it does. It gave you 2 placeholders. One is the string, which is the get name. The other one is the 2f, .2f, which is the get balance. With me? Okay. Again, system out print line, same thing. String, another float, placeholder, and then call the method that returns the string, call the method that returns the balance, both of them separated with comma. So parameter list separated by comma. Okay, delimiters. Come over here, enter the deposit for account 2. I take the value in input, next double, store this value in, and I add my value to my deposit account. Then account to deposit amount. So this is where it's stored. So whatever value that you input is now stored in account 2. And then I again print out account 1 and account 2. So again, get balance, get balance. Okay, so when you run it, 50, 00, account 1 2553, adding 2553 to the account balance, so adding $50 to this 2553. John Green balance 7553, John Blue balance 0, 0, enter deposit amount 123.5, adding 123.5, so now it has 75.53, and John Blue has 123. All right. Now remember that negative balance, they did not take it in, right? Because that was an if condition. So it by default, it took this value in, which is 0.00. So basically what's trying to do is, if you try starting an object with a negative balance and then you ask for a balance, it's smart enough to tell you you don't have any balance, right? Your balance is 0 because I forced it to be 0. Yes, if you have 50 there and then you put $100, now your balance is 150. But you can't fool me by saying, oh, my negative balance at 50, now I put $50, it's $100. No, it's not. All right. Scanner method. Okay, these are the things that you again have seen with the scanner. You see this input.next double. This is a method. So if you're taking a string, you have a certain method. If you're taking a double, you have certain method, next double. Again, if you do not, I do not expect you to remember all these things, but I want you to be able to understand the code. So if you see something like this, you immediately know that this is my object, which is my scanner object. I've defined it as input, dot, and if I'm trying to take a value in, I'm taking a next double value in. If I want to take a string in, I have to call it something else. If I want to take an integer in, I have to call it next int. That's why I take so much time to go through these individual lines of code. All right, scanner method, next double returns a double value. And then it talks about the specifier %f. What is the difference between a %f or 0.2f? Is the precision. 2f means 2 decimal values. Okay, 0.0 instance variable. Okay, again another UML. Private, string, double. You have a constructor, public method, what it takes and what it returns. All right. Now, talk about the primitive types and versus reference types. We will talk about the reference types later on, but right now we are pretty much dealing with the primitive types. So primitive types are Boolean, byte, character, short, int, long, float, and double. Okay. You don't see string because string is the reference. All other reference types, so classes which specify the types of objects are reference types. Again, we'll talk about that more. So primitive types, and these are my variables. Variable of type Boolean are initialized to false. See this? So if you use a Boolean variable and if you do not initialize, by default it is false. So you got to remember this. Reference types, and again we will go more into that. Such variables refer to objects in the program. Actually, you use it. Remember when you created those instantiated, when you said computers equals new computers, that's a reference. So then that object is being referenced by a memory address, and that's what it's referring to. Reference type instance variables are initialized by default to the value of null. Okay. So when you initially define and when you have not put in any values to it, by default at that point it has null. So if you go back to those constructors, remember those PC1, if you had not defined a name, remember you had to define called set name, pass in Dell or pass in Lenovo. Let's say you did not do that, but you actually would call that, you take that object and say get name. What would it return? Null. Because that's not been initialized, but by default it is storing the value null. Okay. This is the part that I am not going to cover here. This part is very, very simple because they do a Java FX, but for doing this, you have to download a program called um, there's a plugin that we download to use the JavaFX. It's called Scene Builder. The reason I'm not going to cover it this time is because actually I stopped covering it from last time. Scene Builder is very finicky with the compiler, the JDK that we use. I've always ran into problems. It gets very specific on which computers you're using because you have to add that plugin. You have to also get a few other things to get that scene builder to work, and sometimes it works, sometimes it does not. JavaFX provides you with multiple ways of creating GUI. Java has an older way, which is the Java Swing, which you actually saw in the very first assignment when I said J option pane. So you import a library and then you use the J option pane, which uses the Swing library. However, JavaFX also allows you to do something like this. So what it does is when you create or using a scene builder, you actually create a window like this, and then you can create a little text box. You can input the value in the text box and click on a button called submit, and that will come back and create another text box and give you some of the value. So it looks really nice with a GUI output, but you can do it with multiple ways in Java. JavaFX is the newer version that allows you to do things. It's a little easier, but that scene builder program, is a little finicky about it. So you can also do things with GUI in Java. So these are the kind of things that we can do. I created this program, and then I can drag, so I can create a dragging bar like this. So, and again, there are some programs I used to do with the scene builder where you drew an object, a rectangle, and you do multiple squares inside. You could actually go into one square and color it green, color it red, and you can have a dragger where you can increase or decrease the shading. Okay, so it does allow for all these things, and this is basically an output over here using the scene builder. And every chapter that we have, it actually gives you the GUI interface that you can do with a scene builder. Again, in most of the time, we will not get into it. We will stick with the console output. Okay. And I think that is pretty much all I have to cover. Back here.